In this video, we are going to integrate using Fourier series. So you have this integral from 0 to pi by 4 log of 2 cos x dx. In one of my earlier videos, I have shown that uh, I have proved the log of Fourier series for log of 2 cos x. I think its name is Interesting Sums by Dr. PM, and the card is over here. Okay. So now, if you know the series, we can begin integrating the series, the Fourier series for log of 2 cos x is like this. Its sum from n equals to 1 to infinity, negative 1 to the power n plus 1 cos of 2nx over over n. So this is the Fourier series for ln of 2 cos x. Now we'll use this series for evaluating this integral. So we will have integral from 0 to pi by 4 and summation from n equals to 1 to infinity and minus 1 to the power n plus 1 cos 2nx by n dx. Now since this is converging, we can change the sum and the integral. Summation from n equals to 1 to infinity, integral from 0 to pi by 4, minus 1 to the power n plus 1 cos 2nx over n dx Now we'll integrate it. Summation from n equals to 1 to infinity, and this will be negative 1 to the power n plus 1 is constant, and here sine 2nx by 2n dot n, and integrating from 0 to pi by 4. And then now we'll evaluate with our function in the limits. So we can just first take these constants out in 2n square. Now at pi by 4 we will have n pi by 2, n pi by 2 over here, and sine n pi by 2 for 1 it's 1, 0, 1, minus 1, n pi by 2. So for n pi by 2, okay, it's no n pi by 2, okay, sine n pi by 2 will be there, at 1 we will have sine pi by 2, it's 1, and at 2 which is sine pi, that is 0, minus 1 and 0 and 1 and 0 and so on. And now this will be at 1, this is 1 itself, okay, here minus 1, again at 3 this is 1, minus 1, 1. So when we multiply this, we get 1 minus 1, 1 minus 1, so on. Okay, so we get what kind of series it will be from this evaluation. So it will be something like this. First 1, and then for n equals to 2 it's 0, and so we need to do it something like this. We need to directly evaluate the sum over here. Again, we can do it like this. What we can do is so we can just take 1 by 2 out first, and we noted that we would have 1 by n square, and sorry, 1 by 1 square, 1 by 1 square, and minus 1 by 3 square, and then plus 1 by 5 square, minus 1 by 7 square, and so on. We just noted that this occurs just a little before. Yeah, because it was 1 for this thing was 1 for 1, minus 1 for 3, plus 1 for 5, minus 1 for 7. So here it was n square denominator, so we get this. Now for 0 it's minus of 0, so that's 1 by 2, and this is known as Catalan constants, so g by 2. So g by 2 is our answer. Thanks for watching. I look forward to seeing you in the next video.